Good morning, ladies and gentlemen. My name is Alexio Picco. I'm the Managing Director of the Circle Group, and I welcome you to the Connecting EU Inside Spring Edition 2021. We started beginning of the week, and we had in the first 2 days already a number of very interesting interviews and events. This morning we are, switching to the rail sector, and we prepared for you a very interesting session that is mainly focused on some innovative applications in the rail sector in terms of digitalization and operations, such as optimization algorithms and digital twin applications. But before, we decided to give a little bit of a frame of what is the rail sector in terms of innovation today, and that is why we invited the European Railway Agency and some top-level experts in the field to give a little bit of the frame. Specifically, we have very distinguished panelists. This morning, we had Michael Varga, Project Officer in Telematics from the European Railway Agency. He's going to, give a little bit of a frame specifically in how the directive and the standard on TAF TSI is going to be extended to other logistics operators that are not, merely railways operators. And then we have Lars Dieterding, Executive Director at ACON of the Siemens Group, giving the overall frame of the innovation of systemic approach in the railway sector nowadays. Emanuele Profice from the Port Authority of Genoa, that is shaping how an end user is going to adapt and use those innovations to a specific reality. And then the two core topics of the day in terms of optimization with Veronica Asta, that is CIO of Optimisi, and Roberto Revetria for Digital Twin, that is partner of Mesa. So the idea is to have their presentations, and then we can have also a little bit of a chat and discussion. If you have some questions, please use the Q&A tab, and we are going to receive and manage your questions. The forum will be recorded and also to be used later on in web and social networks, and slide will be also distributed after the event. So without losing any more time, I will ask the first speaker, Michael Varga, to come on stage, and I'm going to present him a little bit and then give the floor to him. Michael is a project officer in, good morning, Michael. He's project officer in telematics at the European Railway Agency. He has experience in IT project management, EU rail legislation, and rail passenger freight distribution. He works since 2006 at the European Railway Agency, drafting various telematics directives. His task at ERA is to make telematics interoperability happen in Europe. That's a challenge. That's a challenge, Michael. For this purpose is super users implementation of telematics. Before spent 9 years at International Union of Railways, working IT projects and development of IT protocol interfaces. So it is really, a top-level expert in IT and rail operations. So thanks for joining us. It is really a pleasure to have you here, Michael, and the floor is yours, Michael.
Okay, Alexio, thank you very much. I hope you can hear me. I try to share my screen and my presentation. Please tell me if you can see it.
Still not.
Oh, then something is. Okay.
It's coming. That's fine, Mark.
Okay, so as it was announced by Alexio, I will present you the standards which are used by the so-called TAF TSI. TAF TSI is the telematic applications for freight, and TSI is technical specification for interoperability. It's of course a standard setting tool of the European Union, but it's at the same time also legislation. And as you can see from the logo in the bottom left part of my presentation, I'm coming from the European Union Agency for Railways. So if I would like to give you a snapshot about the functions of the TAF TSI, you can see that we ensure basically from the heavy rail point of view, the information exchange between railway undertakings and infrastructure managers, such as pass request, train preparation, train running forecast, and so on and so on. But we also ensure the communication between the railway undertakings. Very important to mention here the shipment estimated time of interchange interval and the wagon movements. And of course, we make also some requirements for wagon keepers to store their data in rolling stock reference databases in a given data set. And of course, we have common components as mandatory part of the TSI here. We are talking about the mandatory coding of companies and of locations which are appearing in nearly all of our messages. That's why they have to be encoded in a centralized manner. So if we go further and we give you the TAF TSI, not as a snapshot, but as a process, you can distinguish between the planning, operation, and after operation process. And of course, we start with the consignment note and consignment order from the left-hand side. Then we go to the pass request, then to train preparation, train running forecast, service disruption, and wagon movements, including the estimated time of arrival of the wagons or the consignments to the siding of the customer. What is very important, what I already explained to you, it's not only a standard, it's a legislation, so it's mandatory for railway undertakings, infrastructure managers, but also for combined transport operators, for port authorities now, and also for the operators within the terminals. And this new version of the TSI has been published in March 2021, and it is visible if you click on the link which is indicated in the middle of the screen, and then you can download this legislation in all the official EU languages within the European Union. So what we do in detail for every function, I've mentioned a couple of slides before, we describe the sequence of the exchange between the different actors. For example, you can see on the first row the different actors such as IMs, infrastructure managers, RUs, railway undertakings, shunting operators, terminal operators, and then you can see in which sequence or in which alternatives they can exchange which type of messages during a given function within this TAF TSI. And to give you a flavor how the messages look like, they are all encoded in XML schemas, and here we give you a small example about a message which is called alert message, and the purpose of this message, but it's just an example to give an information to your business partners that there will be a deviation from the commitment estimated time of arrival, and you also deliver the best estimation for the actual estimated time of arrival what you have today. So what is also very important in this TSI that as you have seen on the previous slide, we have everything encoded in XSD and XML, but we also accept other formats under the precondition that they ensure so-called soft compliance to our XSD. And it means that if you have a different message content or format, for example, you have TXT, Edifact, or just simply an Excel sheet, it's not the end of the world, because if your message carries or your dataset carries the mandatory elements for the TAF TSI XSD, then we can convert it, or your business partners can convert it into the TAF TSI format, and then you are compliant or soft compliant to the TAF TSI, and you can also take part in the message exchange with your business partners. What is also very important that we have included special provisions for the combined transport and the combined transport operators. We have included them into the TAF TSI with their rights and obligations to exchange data with the business partners in the logistic chain. And they have also the right to get information and to give information about the train preparation, train running, and estimated time of arrival. And they have, of course, easier access to data within the TAF TSI data exchange, which is the so-called Rotterdam Declaration signed by the railway undertakings in 2016 in Rotterdam. So it's just an example for you. You have probably heard that some of the combined transport operators, they use so-called EDIGES messages. Here you see an example, EDIGES S23, which is a wagon in train composition message. On the left-hand side, you see EDIGES XML message, which is XML, but the structure and the format is different compared to the TAF-TSI, which you can see on the right-hand side here with the TAF-TSI train composition message. And here you can see the EDIGES message before transformation. It looks like an XML, but it's not exactly the same as our message. After the transformation, we get the real TAF-TSI train composition message, which means that if you are a combined transport operator and you use your EDIGES type message, and we can convert it into valid messages into the TAF-TSI, then you are taking part as a full member with compliant messages in the data exchange within the users community. So this is the state of the art and the main functions of the TAF-TSI. What is still very important and to be done is to include into the TAF-TSI at a later stage an enhanced version of the estimated time of arrival. We are also talking about the QETA, but I think the other panelists will tell you more details about these elements, and also ETP, which is estimated time of for the pickup. It is also an important indicator for the combined transport operators. And of course, we would like to include this enhanced new estimated time of arrival, or ETA elements, into the TAF-TSI in the nearest future, where the rail sector together with the IT providers will validate this new model for the estimated time of arrival. I'm at the end of my presentation. I hope it was interesting and more or less understandable for you. If you have any questions, please don't hesitate to raise them. Thank you very much.
Thanks a lot, Michael. It was quite precise and informative, and I do believe that the extension of TAF-TSI for in different directions. One is, to facilitate the use of TAF-TSI to have this soft compliance here, for instance, from multimodal transport operator, combined transport operator is essential, was essential. You remember that we discussed together some years ago, and we did some work together. And this is quite important. Currently, we are working in a CERT project called iRail with a number of countries that are implementing TAF-TSI for railway undertakings, mainly in Italy, Portugal, and Spain. But then there is the key issue of how to extend the use in whatever else is outside, taking not only into account the combined transport operator, but for instance, the port authorities, when they have the role of infrastructure managers for shunting operations, that are again another aspect that we are dealing with, or exchange of specific key information with customs, for instance, related to the consignment note, something that could be related to the consignment note. So thank you very much. It was really important, I think, quite informative. We need also to study the quite new regulation, because it's just one month that is there, and thanks for that. And it was very useful. Let's go now to the second one, meaning having a little bit of a system approach in the rail sector, and the best expert to do that for sure is my friend Lars Dieterding, that is executive director of Acon. Acon is a company of the Siemens Group. And just to introduce Lars, he's graduated in transport engineering at the University of Hannover, and for more than 25 years, he has gained experience in research and expert analysis activities in all areas of international railway transport intermodal logistic chains. Now he's executive director of Acon, responsible for freight and logistics department, as well as the coordination of Shift2Rail activities, the joint undertakings on rail. Lars Dieterding is a Shift2Rail governing board member, chairman at UNIFE, chair of the System and Technology Working Group at ALICE, the ETP for logistics in Europe, vice president of New Opera, and member of the Digital Transport Logistics Forum. As lead consultant, he is involved in plenty corridor studies and in market studies of European railway freight corridors. He was coordinator of several research projects such as SpiderPlus, VWAS, CREAM, Trend, Tiger and Tiger Demo, by the way, something that we did together many years ago, and Bravo, aiming at the organizational and technological improvement of the transport sector. So it's really a pleasure for us to have you together with us this morning. Lars, the floor is yours.
Many thanks, Alexio. Good morning, dear ladies and gentlemen. So I'm just sharing my screen. I hope you can see it now.
Yes, perfect.
Good. So I tried to put a lot in this presentation, but in 10 minutes, it's not that easy. When talking about a modern digital rail system as a backbone of reliable and green transport, and I think this is what we all want, it is clear that all innovations must be interlocked. So the digital freight train is a prerequisite for enhanced efficiency and safe operation. And in combination with automated driving, the operation can then be further optimized, energy can be saved, and maintenance efforts can be reduced. And tackling today more a little bit the last mile, also in the last mile, productivity can be significantly increased by automated shunting and train formation. But also here, the same applies as for the whole network. Effective planning and capacity management is of key importance to use sometimes scarce available resources to a maximum. And at least, the continuous availability of resources needs to be ensured by innovative solutions for predictive maintenance and technical support. And the better the various components fit to each other, for sure, the better the final result is. And that's why we as Hakon are happy to be since some years part of the most diversified and vertically integrated mobility company. When Siemens decided to acquire Hakon as market leader for timetable management and mobility planners, they just completed their portfolio for the new digital age. And for us as company, which always focused, as you learned from Alexio, on being innovation driver, it got much easier to push things forward in a system approach. And now in close connection with a bundle of all kinds of rail infrastructure products and solutions, state-of-the-art rolling stock, and the latest cloud-based customer service applications, we are able to push rail as part of intermodal solutions. And intermodality, multimodality is, let's say, the central of our company. This drive for innovation is the same with our colleagues for Siemens, and which invest twice the amount for R&D as the following two competitors on the market together. So that's why I was very happy to join them. So there's just a perfect match. And with both companies being key actors in the current Shift to Rail program, we even extended our endeavors to push the rail system as a system. And this in close cooperation with our competitors and customers, because it's so important to improve the interoperability of the various systems. There are a lot of legacy systems in place which have to be integrated and so on. And for sure, there's not enough time today to talk about all the latest developments, but I selected some topics connected to rail operation, last mile, and shunting for a short introduction. So one important topic in Shift to Rail and also in the following joint undertaking is the evolution of yards. Throughout Europe, there's a whole range from classical shunting, which is still dominating, I must say, via assisted shunting to partially automated shunting yet. And within the last years, a lot of developments happened to allow at least a low automation. So this includes real-time information of carriage location, automated calculation of required shunting movements, automated route setting, grip retarders instead of drag shoes, and for sure the planning process. And with the things on the right side, so the developments for partial automation, for example, with autonomous shunters, these are ongoing, these developments. And as soon as also the often discussed now digital automatic coupler is rolled out, also the full automation can be finished. So then hopefully we have finished all our goals, but you know, there will always be new topics. And as for the overall rail system here, just as an example from the hump yard, also in the yard, the various components are important for a full automation. So even if the automatic Goa 3 or 4 shunters might be the most impressive component, and the yard management system might be a central part, there are many more developments needed for full automation. And besides the yard automation itself, also an improved operational planning and integration in the network is of high importance. And here, one tool from the Hakon TPS family comes into the game. So it supports the pre-planning, the planning, and the live operations with the respective workflows. And there are several extension projects ongoing with customers and also connected to Shift2Rail. And as it is case for most of the TPS products, it's in the meantime for sure a browser application which can be used from both sides, the planner, but also the capacity requester. So I missed to say what TPS means. So TPS originally stands for Timetable Planning System, quite easy. But in the last decades, it developed to a complete system also for network management, data integration, track work planning, train path ordering, and much more. It was developed from the very beginning, which is 30 years ago, the initial start, to be kind of a digital twin. So with a very detailed microscopic infrastructure model as basis, and a detailed modeling of the control and safety technology. And being used for the various planning stages at our customers, there's for sure the possibility to manage various data versions or temporary infrastructure restrictions as overlays, respecting the respective implications on the planning and operation always. And this can not only be used for local, last mile or national areas, but also to plan and manage complete timetables of international corridors or maybe later on even on a European level, as it is developed for the parallel use of more than 1,000 timetable planners working on the same database, on the same timetable at the same time without problems, having still a consistent data set. And it's also important that the system includes a precise dynamic runtime calculation engine, which is with an automated and let's say real-time retiming of all trains after the changes of relevant data. So this is especially important when numerous users are using the same data set at the same time. And it's also very important, besides for the realistic and accurate planning, when it comes to the support to support the real-time operations. And this is done in another quite new member of the TPS family, the TPS Live tool. Some of you might have heard about TPS Online before, which is in fact the same tool but has been renamed last year. And as TPS Live is based on the same model as TPS Plan, it's using the same detailed macroscopic model and functions. But in addition to the imported offline timetable from any planning system, it is receiving and processing real-time information about train positions or any other affecting input or obstacle. And based on the generated online timetable and the train positions, a live runtime calculation is leading to a live forecast. So the system can then automatically detect any resulting conflict for any specific train in the network. And most important, it can propose a set of potential conflict resolutions. Depending on the setup, these suggestions can then be used by the responsible dispatcher to take better decisions, as they know in advance which effects their potential decision might have for a specific train run or for others. For the moment, being a decision support tool, the system will learn from the decisions of the dispatchers, because they are the experienced persons at the moment and they just get support. But with this, also a later full automation can be prepared. So learning from the best we could say. And more or less as a side product, the system also provides an estimated time of arrival. So Michael talked about this for the various points in the train run based on real-time operations and conflicts, which is naturally of higher accuracy than a prediction just based on historical data, which we are also doing in cases where we have not the detailed microscopic model behind. So it's just, let's say, like a bridging technology to use AI based on historical data. Yeah, and the question why accuracy is of such high importance was tackled by us in the ELETA project. Some of you might heard about this some years ago, and also in some running projects. Also, Q-ELETA will be a step in this direction, even if the focus is a little bit different. Here are just some screenshots of another product called Smart VMS, where our ETA management platform is based on, which is used for real-time fleet and train management. In this case, the targeted user group have been the dispatchers of the intermodal operators, but it could also be the terminal or yard managers, which need to know when the trains will arrive at their place. And for them, it's important to understand in the live system and not afterwards, how reliable and accurate the predictions are, or at least have been for a specific train run and measurement point in the past. Because only then they will take operational decisions based on this. And you can see it here on the right side. There are two different ETA calculations provided. So for this train run, which is delayed for 51 minutes, you can see it. And you can see that one prognosis is first day at 3:40, the other one is 2:51, and with the colored part right to it, you can always see how reliable and accurate this, from this specific algorithm, this ETA was in the past. And so the dispatcher knows exactly, okay, don't trust the red one, use the green one if you want. And this can easily be configured and so on. So yeah, unfortunately, I believe my 10 minutes are gone. Sorry, Alexio, for the delay, and many thanks for your attention.
No worries, that is okay, Lars. It was also quite useful to understand and to go from a systemic approach you started from. That is important to frame the next also presentation, and how exactly the optimization and the digital twin are, exactly framed in this picture. But then you gave us also a very clear picture of detailed solutions in terms of, for instance, the work on the ETA, work that you have been doing the last 5 years at least, I think, and that shows also clearly how a thing that could be seen as a simple one, say, okay, the estimated time of arrival is, okay, what is the estimated time of arrival? No, it's not so simple at all. So there are different ways to estimate and to calculate, and improvements are needed in order really to have the optimization of the sector in general, and still some work has to be done. So thank you very much. Let's move to the next one, and let's move to the end user side. So I kindly call on stage Emanuele Profice, that is EU Police Officer Representative of the Western Liguria Seaport Authority. He received his PhD in Logistics, Transport and Territory Economics at Italian Center of Excellence on Integrated Logistics, University of Genoa. He's employed at Autorità Portuale, Sistema Portuale Mar Ligure Occidentale, formerly the previous Port Authority, since June 2006, working in the planning and development area of the Port Authority. The last years, particularly worked in European policies and projects on transport and infrastructure, with particular reference to innovation, environmental, and digitalization. So, perspective of a port in this area. Emanuele, the floor is yours.
Thank you for the introduction and the opportunity to illustrate our vision in this important webinar. I will deliver you a very broad presentation of our approach to the innovation in the field of rail, in particular sector of the port. Here you can see some key data of the Port of Genoa, now merged with the Port of Savonarado and becoming one of the most important ports in the Mediterranean and one of the main gateway port in the southern part of Europe. So our perspective is the perspective of the Rhine-Alpine corridor, which is our key axis of penetration in the market, and represents our way to assess the European market. Nowadays, our traffic basin is more focused on Italy, but with these important investments on the rail infrastructure side in Switzerland and also in Italy with the tunnel of Terzo Valico, we are confident to be ready to intercept also traffic from Switzerland and southern Germany, so becoming the southern gateway of this important corridor. So our vision in this field is to couple the very huge investments we are planning on the seaside with the improvements that are on the land sides carried out by the infrastructure manager, with particular reference to the Northwest Italy. The Terzo Valico is one of the most important works that we are looking at, and all our measures and action in the rail infrastructure sector are focused on the foreseen end of the works of Terzo Valico. So we have to be ready for 2024 with a set of actions that are developed on these three main strategic axes. Some infrastructure awards that are connecting to the whole revamping on the Genoa rail node, which will separate the rail commuting traffic from the long distance and the freight traffic, and the revamping on the old port last mile rail connections. We have an important, relevant as a port authority investments in this field that is mainly focused on these topics, so increasing the efficiency and the connectivity. We are going to be compliant with the European standards of rail infrastructure concerning train length, electrification, and we are also going to enhance the safety of operations. The second axis we are dealing with is the management and organization of rail services, for instance, through incentives to the rail sector, and we are looking for a new model, for instance, for the shunting operations in the port. And last but not least, the innovation and digital pilot projects that are the object of the today's presentation, and that will be deepened in the following presentation by the other colleagues, but that are here summarized. So we have an approach based on these various pillars: the signaling system together with the infrastructure managers, the optimization and digital twin that we will see later, the new functions of our port community system, specifically dedicated to the rail sector, and I will go further on this point. And finally, the gate automation and the interoperability with the custom agency systems, which is very important to complete the whole port and logistics cycle. the function that we are now developing also with the support of Circle in the field of port community system are based on a bottom-up approach. For us, it's very important to deal with this innovative project and pilot project with the support of the whole port community and all the actors that are involved in this specific case in the rail sector. So we are now testing some new functions with all these actors, and within the end of the year, we plan to deliver the first function and digital services to these operators, in order to better manage and program the port rail operation. The scope is to receive and deliver the information to all the actors on time and in a way that they can better manage their day-by-day operations. This is very important to foster and to push on the rail transport in our port, also in order to try to get more market share in regions that are far from the port. This is the screenshot of one of the first output of this innovative project. In particular, this output was developed in the framework of one European project, which is called eBridge, funded by European Union with CEF Connecting Europe Facility funds. And this rail dashboard allows the port operators, the terminal, and the other operators to gain in advance the data concerning the estimated arrival of train, the delays, and the changes in the timetable of the train. This is very important for the operators to better organize their operation. As I told before, we will see the other products in the other project in the other presentation. So I thank you very much for your attention, and I give you, Alexio, the floor. Thank you.
Thanks a lot, Emanuele. It was quite important to see how the Port Authority is framing different initiatives in the field of digitalization of the railway sector, in which the next two presentations that are a little bit the core of this morning, the optimization and the digital twin are really have a very relevant role in this respect, together with all the other operations. And I think it is important to stress one point, at least personally, in terms of extending and making the different words, let's say, interoperable, is the so-called PCS rail. So the extension of port community system as an interface to the rail shunting and to the rail management operation. This is a key factor that the Port Authority is bringing on. And I think it's quite an achievement, ongoing, let's say, development that we could achieve soon. Okay, thanks a lot. Let's move to the core part of the day, in which we have first the port rail shunting optimization. So I call on stage Veronica Asta, that's CIO Optimizi. Veronica is graduated in Maritime and Ports Economics and Management in 2017 in the University of Genoa. She attended 3 years PhD course in Logistics and Transport at the Italian Center of Excellence in Logistics, Transport and Infrastructure based in Genova from 2017 to 2020, exactly focusing on optimization and operational research techniques. In 2021, January, very recently, she founded Optimizi, an innovative startup for processes and decision optimization. She is currently guiding Optimizy for providing optimization solution as decision support system for real problems. So it's a pleasure to have with us this morning, Veronica. Veronica, the floor is yours.
Thank you. Thank you. Good morning to everyone. And thank you, Alexio, for the presentation. I'm here today to speak about the port rail shunting optimization, which is a pilot, as already said by the Port Authority, Emanuele from the Port Authority of Genoa, that we are developing together with them under the European project eBridge. So in particular, we are focusing on scheduling and rescheduling of the shunting activities, and something that we already learned about Lars before, but different in a different context, that is a port system. So just an introduction, because Optimizy is a real new innovative startup that provides an easy approach for decision support systems based on operational research and optimization techniques. So we takes advantage from the integration of different and transversal skills, of course, mathematics and optimization, because we based our approaches on optimization models and algorithms, but also logistics and transport, because we focus our work on this field, and of course also economics, because we wanted to give an holistic approach to real problems, take into account a lot of real operative characteristics that real problems have. So Optimizy has a strong collaboration and partnership with the Circle Group, and we are working together in this new line of business that has been launched in 2021 for optimization, and this is called the line of business optimization for .0. Within this collaboration, we are dealing with different optimization projects. One of these is the optimization of the rail last mile, and is the one of which I'm talking today. I just introduced the concept of rail last mile because we are in intermodality system, and rail last mile is the last leg of rail transport that we can consider from the last maritime port of origin or destination. It depends if the cycle is export or import, until the last inland terminal connected with the port. So we are dealing with this system, and in particular we are focused in this project to the port rail shunting process, which happen in a particular context, which is the maritime port. So we are speaking about an important exchange node between the rail traffic, the rail transportation, and the maritime one. So in this context, you can see a scheme, a logical scheme, and a simple one, but just to generalize the system in the lower part of this slide, where we have a rail station outside the port area. Then we have the port area, which comprehends the maritime terminals, of course, but also a shunting park that might be one or more, but in general, we have a station, we have a shunting park, and then we have maritime terminals. In this context, we have different transfer operations for transferring freight trains from the rail station outside the port area until the maritime terminals inside. This is a particular process because it's very focused, and it involves different stakeholders. In this process, we have some main operations, and the problems are, the optimization problems are two, as I introduced before. So we have a scheduling problem, port rail shunting scheduling problem. This is the name that we gave to the problem. And it consists in scheduling the shunting operations, so the main transferring operations within this system. We have a predefined planning horizon, which can be, for example, a week, a standard week, if we wanted to plan a week today for the next months, but we can also schedule for less than 1 week, but we can schedule for a day or 2 days and so on. We have to respect with this scheduling a lot of operative constraints that arise from resources. Of course, we have rail tracks to consider the feasible path in the system, but we have also to consider shunting teams and engines that are the main resources of the shunting company in order to provide the service of transferring these trains. Then we have train paths, because we have arrival and departing timing that are fixed, that are predefined, that are a commercial issue between the railway companies and the National Railway Infrastructure Manager. And in this way, we have this as strong constraint, because we have to respect them, because the other operators of the rail system organize themselves with this timing, with this agreements, and so we have to respect this timing. But also we have to consider a particular another particular operator that it is not a common rail operator, but it exists in the port system. So the terminal, the maritime terminal. We consider some time windows for pick up and delivery the train, for taking into consideration the maritime terminal availability. In this problem, the objective is to minimizing the waiting time for the trains to be transferred while performing all the operations, because the objective of the shunting company is to perform all the shunting operations with the respect of all these concepts. The other optimization problem that we are dealing with is the port rail shunting rescheduling problem. Here is the problem is quite similar, but it is different, because in this way we don't have only the trains to schedule, but we have a plan. We might have a plan, and we have to reschedule this plan in order to take into consideration unpredictable events that you know, in rail traffic there are a lot of unpredictable events, because every day there is an operative management of the train. So we have a lot of unpredictable events. In this problem, we wanted to reschedule the plan. That can be 1 day, 2 days, or more. It depends. It doesn't matter. But what matters is that we have to respect again all the constraints arising in this system. Here, the objective is extended, because we have to perform all the operations. We have to minimize the waiting time, but we have also to minimize as much as possible the distance between the new plan and the previous one. This is because we cannot replan something with changing everything. This is really important, because this process involves a lot of stakeholders. And if we give a plan, or if we have a plan, the other operators organize their operations with respect to a plan, to a schedule. So we cannot change everything. And so this is another objective that we consider in this optimization problem, to keep as much as possible the planned timetable as before, as the planned one. So a lot of unpredictable events that we can consider, of course, delays of trains delays every day, changing in time windows of availability of the terminal, because the maritime terminal have to consider their operation with respect also to the ship schedule. So we cannot not consider these particularities in port system. The change of operation duration, because when we schedule, we can, of course, give as input a kind of standard duration depending on the speed of the operations for transferring trains. But sometimes some problems can arise in these systems, and so let's say, for example, the cars discharging. So we have to consider that we can have also changing in the operation of the duration, in the duration of the operation. We consider also suppressed trains and extraordinary trains. So this, I already said, is a pilot project with Port Authority of Genova, based in focusing the San Pietrarena basin of the Port of Genoa under the European Project E-Bridge. I will show you some screenshots of the user interface that we developed in order to be able to exchange information with the optimization tool that we developed also. And this is a user interface because, of course, the information can be digitalized, have to be digitalized, but sometimes we can have some information that are not yet digitalized. And this is a user interface that we can use to include all the data needed for the optimization. And then we can use it also manually. But the objective is to, of course, to make it with interoperability machine to machine in order to have the real data in time. So you can see this part, we can insert the data for the trains to schedule. Then we have this green part that we can manage the resources availability because we can change the working shift of the shunting teams, and we can, of course, also change the availability of the resources, and also the planning horizon to schedule from the starting and the ending time. This is an example of the output. This is a table example because you can see in each line it's represented train, and then we have the train path, so the arriving and the departing time and the date. We have the cycle, if export or import. We have the origin destination, and we have the terminal, the maritime terminal of origin destination in this system. And the output of the optimization of the scheduling problem of the scheduling model is to provide the date and the time for the starting and the ending of each main transfer operation that we are trying to plan. So in this way, we are sure that this timetable, this plan for the shunting operations takes into account all the constraints, the operative constraints that we consider, that we put inside, that I already told you before. So, of course, from the table visualization, we can change something. Of course, the operators can have this as a support for the decisions, and then they can change something. But we can also have a graphical representation and whatever we want. But the concept, the core of the problem is to give a plan, a schedule for the activities. So thank you for your attention. I hope everything was clear, and I put my email if you have question, or I'm available, of course.
Thank you very much, Veronica. It was very clear in the taking into account the complexity of the issue, because it is not certainly an easy task. Even you are Optimiz is trying to make this easy, but it is not. So it is definitely an improvement that could make the shunting operation more effective. And if we really want to boost rail operations and to shift even more, containers from trucks to rail, we need to have tools to make this more feasible, more attractive, less expensive at the very end of the game for the railway sector. So thank you very much. Let's go to the last one, that is the optimal final step of what we have been discussing this morning. So I ask Roberto. Okay, Roberto is already on stage. Roberto was Deputy Director of the Italian Center of Excellence in Logistics and Transportation. He also currently involved in many top-level management training courses, such as risk management, decision support systems, project management for healthcare. Since 2008, he is also special appointed consultant for the Vatican City, where it supports the AAPSA president in the development of IT projects. Roberto, for digital twin in rail maritime application, the floor is yours.
Okay, thank you very much. I'm trying to share my screen. Good morning to everyone. I hope that now you will be able to see my screen.
It's coming, yes.
Okay, thank you. I'm
Still
putting
not,
in.
but it's coming.
Okay. Okay, I hope that now.
It's okay, Roberto.
Okay, perfect. I start my presentation. Okay, I hope you can. Okay. Good morning. The topic of my presentation today is to present the solution for the digital twin that we have prepared for this particular pilot project. And in particular, this digital twin is devoted to provide simulation and visualization support for the optimization algorithm that has been just presented by Veronica a few moments ago. This methodology, we're starting from a previous set of experience, in particular for the correct identification of the methodology that needs to be implemented for realizing a digital twin in this sector. And in particular, two main different technologies were used, investigate, and combined in this digital twin. One is related to the use of discrete event simulation that is known as to be a standard in many industrial applications and also in many logistics application of the digital twin. However, due to the particular characteristics of the rail shunting, it was necessary also to add some continuous part simulation, especially for the motion of the train, for a more credible representation of the physics of the shuntings and on the placement of the train. For this purpose, we have implemented in Optimize. Optimize is a tool that it was implemented by Mesa Group in order to provide support for the digital twin. The interface that we have designed in particular allow several functions. We do have the possibility of showing the actual utilization and the actual status of the various entities that are present in our digital twin. At the same time, we have, as is possible to see, a GIS map in which all of the rail track has been represented. And also we have a panel in which the several events that could be interesting to see are presented. In particular, this event can point out, for instance, any issue or problem that can come in the implementation, in the practical implementation of the schedule that has been presented. And so it's possible to review and rehearse the possible scheduling in order to verify if this was correct or identify if there are any suggestions that can be made. All of this panel is totally interactive, and we do have the opportunity to deploy, as it was done as a application on a desktop, so it means on a workstation, or can be implemented and integrated in a cloud environment in which can be also used as a service for other applications. Along with the 2D representation of the GIS, we do have the possibility to highlight also a 3D representation. This 3D representation in particular is quite useful in order to better understand the physics of the mission that has been implemented. And as in the image on your left, you can see, for instance, that we have several virtual cameras, some of them also on board of the train, that allow the possibility to see virtually and to fly over the entire terminal and the entire railway yard in order to physically visit as you were able to walk in person inside of the railway. This is quite important because it allows the possibility of a broader view of all of the operations that are currently in the way to be implemented, also in the operation that has been scheduled by the using of the optimization. Of course, all of this digital twin is perfectly connected with the data, and in particular, it received the inputs from the optimization that has been just described by Veronica. And so we can have a one-to-one correspondence of what has been scheduled to what is being representative in the digital twin. In particular, the scheduling algorithm, it provides the information related to the mission. We have in the digital twin two different kinds of mission. We have what we call the piloting mission that are using mostly the external locomotive that is entering into the terminal. And then we have the maneuvering or shunting operation that normally I use internal locomotive or locotractor or any other method that it is used to displace the wagon and the cars along the railway. The piloting mission in particular has been coded. So we have at the moment several different kinds of mission, and the optimization is selecting during the optimization the right kind of mission that is then sent to the digital twin that is able to represent. In particular, all of the trains that are entering are treated car by car, and we have a perfectly correspondence between the car that is being represented and the car that is expected to run on the particular track. Related to the shunting operation, we have defined a different kind of atomic operation. These atomic operations are then composed in order to create the schedule of the shunting, and in particular we can have the representation of simple transfer mission, a mission that will allow also some regress point in order to reach point in the network that require special maneuvering. Then a simple coupling and decoupling that is used when you need to create or to detach a locomotive from the train. And then the operation of splitting that allow the possibility of taking one convoy, taking one train and split into several parts that has to be managed correctly into the system, into the rail yard. And then we do have also what we call the special operation that are particular maneuvering that require to have a special sequence. As is possible to see, if the digital twin is detecting some conflicting or some issue that maybe are arising from the fact that the digital twin is able to simulate exactly the physics of the displacement of the container, it will pop up the user with this information. This could be useful in order to detect the problem before they took place in the rail terminal. We have a set of entity. This set of entity has been mapped on the same entity that are used in the scheduling algorithm. So we have a perfect correspondence among these two words, and in particular, what is exiting from the scheduling is the input of the digital twin and can be represented very, very easily. The mission and the mission sequence, so is then a set of the operation as they are provided. That can be provided or directly by hand, means directly by inputting, or by providing as the output for the scheduling. In this way, it's also possible to compare different alternatives and also to analyze a special situation that may be of interest in the management of the terminal yard. The mission parameter are specifying all of the details of the simulation. And in particular, we have creating a general set of information that can be used and adapted to very different terminal, very different kind of application. So this pilot project is just one of the examples of the application of this particular tool. More inside of the digital twin has been developing special building block that are implementing the typical physical movement of the train. So it's possible to have acceleration, deceleration close to reality, also to have time for splitting, for shunting, and also the rule that are used by the train to go from one location to the other one can be easily mimic what are the actual rule in the train. We do have also some building block specific for the item along the network. So it is possible to create a one-to-one representation between the track and the physical track that are then created as a digital twin into this environment in particular. Here you see an example in which you can see the detail of the GIS. The track that are represented are the actual track that are present in the terminal. The system is equipped with an inner GIS. So where the track are really existing already in reality, you don't need to draw the track on your own, but simply you can select the track that are already present in the GIS. However, the system is also supporting the expansion of the network. So in any moment you can drive on your own track, maybe to make some evaluation about a possible future scenario or a possible evolution scenario of the terminal. In this way, this tool is not only useful as a simple digital twin for the representation of what is currently the terminal, but could also be used in order to virtually represent and test in a quantitative way and in an operative way also what could be the possible evolution of the terminal. In the pilot project in particular, we have already selected what is currently the network of the existing track, and then we have also tested by adding some new track that has been planned to be realized in the upcoming year. So demonstrating the possibility also to use this as a design tool for future operation. This is ended up my presentation, and I do thank you all of the speaker and in particular the chairman to invite me in this presentation, and then I will be happy to answer to your question if any. Thank you.
Thanks a lot, Roberto. Quite clear, and the proper complement to all the other presentations. So I think the full package was really quite interesting. We have some questions, and that's the Q&A time. And if I'm not wrong, it's okay, 8:10. So we have just a bit of time to cover it. Two of the questions were raised to Michael directly, and he already answered in the Q&A panel. But I think they are important to be mentioned. The first one was about the soft compliance mentioned by Michael, and the fact that how the common interface could still be needed in terms of certification of the messages. And the answer is that the certification of messages that's in terms of this soft compliance is recommended but not mandatory. And on the European Railway Agency website, we can find a set of compliance reports and the way in which the agency is checking this compliancy. So thanks, Michael, very clear. And the second question was about, again, the WIMO database that was present in the previous version of TAF TSI, in the TAF TSI directive, and what about the regulation? And the database is still in the TAF TSI regulation, but it became now optional, whilst in the previous version was a mandatory one. Let me see if yes, I have some more questions. Michael, I think you answered already. One is for Lars. I can ask all of you to come on stage again, all of you. Lars, I was learning that you and reading that you are working on a feasibility study. That's quite interesting from my point of view. That is about rail collaborative decision making. That is something that is a concept that is running also in other fields, such as in the port call decision making, collaborative decision making, and that it is implemented through something like a Eurocontrol for aviation. So again, a very nice idea of how to exploit a concept quite well working in another sector to rail. Why conflict detection and real-time traffic management are such important in this concept? And how, in a way, the last mile, so what we have been talking about, will benefit from this collaborative decision making?
Yeah, many thanks. So in general, it's a running study, so the final results are not there. We are doing it together with a consultant team, which have done this for the aviation sector for years. And so learning and merging our experience for rail. And what is clear, I think, for everybody, that the situation in the air is different as on the main line. Bypassing is much easier in the air and three-dimensional than rail. And when we are talking about operational improvements, then it's very important to provide the actors with reliable information, as we just had in various presentations, ahead of time, so as early as possible. And to have this, especially on a longer corridor, so on international train line, it's very important that have reliable information about what is happening today on the line. So it's not only about when the train is about to leave. So there is a task to be done by the origin terminal or whatever. But then also for the proper arrival time to detect right in advance where are potential conflicts. So, and this is done in aviation, and it's not clear if this can be transferred or should be transferred to a central point. It's done by Eurocontrol, so to detect, okay, is the demand for a certain region or a certain line higher than the existing capacity because of certain factors. And for this, the detection of conflicts on the complete route of the train is very important, because only then we can give a proper estimated time of arrival, which then can be used by the various systems like the ones also just presented for doing a last mile optimization. And so this is in contrast to aviation, conflict detection is much more important for rail.
Very clear. Thanks, Lars. I have still one for Michael. I mean, how do the European Railway Agency or the Commission ensure that the new regulation TAF TSI gets implemented? So, do you have any specific partners? Are you relying on specific tools, or what is the method in which you are going to check this implementation of TAF TSI regulation?
Oh, I think we lost Michael.
We lost Michael. Huh? Michael, are you there? I can move to Emanuele. In the meantime, we see if Michael is coming back. Emanuele, I was curious to ask you. I mean, not only in terms of rail, but in terms of other modes, and of course, being an intermodal node, this is also affecting rail in a way. What other initiatives do you have in the Port Authority in the area of digitalizations? We cannot hear you very well. So you are okay, Michael. Yes. So sorry, I moved to Emanuele. I come back to you. Sorry.
We need Michael to turn off his microphone in order to hear Emanuele, because it's the background noise that blocks Emanuele's voice. If Michael turn off his microphone for a while, please. We can hear Emanuele better. Okay, Michael is writing me in the chat. He has problem hearing and seeing us, so he has some connection problem. So I'm trying to helping Mark.
Okay, go on, Emanuele, go on.
So yes, as you can imagine, we have also other fields in which we are piloting and developing actions in the field of the digitalization of the port process. For instance, we delivered in March of this year a new tool for the pre-announcement of the arrival of the trucks in the port, also related to the COVID pandemic, so that the truck driver and the operators at the gate do not have to exchange paper and documents. It's all paperless or quite 100% paperless, and it's a very important improvement that we are carrying out in the whole port system that will facilitate the flow of trucks. This project is now based on container traffic, but we are also addressing the problem of other kinds of traffics. For instance, the ferries, so Ro-Ro traffic. We have a lot of this traffic in Genoa and also in Savona. For instance, in Savona, we are experiencing some project of gate automation of these for this ferry traffic, and we are also testing, also with the help of Circle, some smart glasses in a railroad terminal just beside the quays of Savona, Vado, and these, for instance, these smart glasses are performing very well in the operation of the gates, allowing the operator to see all the data about the driver, the truck, and the cargo on it. So the technology advances, so we have to update continuously our project, and we're going to see what other developments we can put in place.
Thanks a lot, Emanuele. Quite understandable all the different pieces and blocks you are putting together. Veronica, I have another curiosity, let's say. When I started many years ago, unfortunately, to work in transport, and I got some simulation to deal with. At that time, I mean, with old processors, I mean, it took really an incredible number of hours to have, an output. So I'm curious to say 20 years ago, it's not the same, of course. So how long does it take the tool to provide solutions to the problem?
Okay, thank you, Alex. This is an important question because we have to make a difference between the two problems. If we are speaking about scheduling, as the one of the characteristics of the scheduling is that we have not a lot, but we have time to plan the operations. In this way, the solution in this moment takes around 5 minutes for a huge number. Around, for give an example, around 100 trains we can schedule in 5 minutes or around that. And this for 1 week. So these are the main elements: 100 trains, 1 week, 1 standard week, 5 minutes. And this is good because we can have enough time to do that. But if we speak about rescheduling, this is different because one different characteristics from the other problem is that we have not enough time. We don't have time, so the rescheduling in this moment is less than 1 minute. This is really important to have a quick answer to our problem, to our rescheduling problem. So this is important.
So a very big step forward. I mean, at that time, the assignment of the, let's say, a certain demand on a public transport network took 1 night. So it was different time. But okay, it is very good to see.
Also, the research is always try to improve the timing. So as faster we are, as better. But yeah, I understand.
No, it's important to have, let's say, a manageable time. Of course, I was sure about that but it was also nice to have the understanding of the range. You know, that's important for the people to understand. Roberto, I mean, I have to extend a little bit because the subject in a way, because many of the events we are organizing this week, they are more on the global package of Green Deal sustainability. So what's the role of digital twin for supporting the transition to a more sustainable maritime port infrastructure, in your view?
Yes, it's an extremely good question, because the sustainability is known to be one of the key of the upcoming recovery plan of the European Union after COVID-19. And for sure, for instance, the rail will play a crucial role in the sustainability. What is really important is that the digital twin can have the possibility of provide also the data and the analysis of the aspects that are related to the environmental issue. In particular, from the digital twin can easily come out the electrical consumption, the environmental aspects that are connected with a particular organization of a displacement, a maneuvering, or a shipment. So I suppose that the digital twin will play a crucial role more and more in the future, and they can be easily adapted also to take into consideration such aspects.
Thanks a lot, Roberto. Let's try to come back to Michael. Michael, can you hear me? Okay, you can unmute yourself. I think, okay, fine. Thanks a lot. And so the question was how the agency, the European Railway Agency or the Commission, ensure that the new regulation, TAF-TSI, is implemented in the member states. If you have specific partners or you do yourself, or what's which are the rules of the games?
Yes, thank you very much, Alexio, for this question. So the rule number 1 is that when you make legislation, you have to always make an implementation master plan for it. We have done it for the previous version of the TSI, and we are working for an amended master plan for the new version. In this master plan, we describe all the functions of the TSI to be implemented, broken down by type of actor, because infrastructure managers have different speeds compared to the railway undertakings. They have, again, different speeds compared to port authorities or to wagon keepers. They have all different financial asset and users communities, but we have to define it. And then after we have defined and agreed this master plan, we monitor the implementation. We have a very dedicated working party where we invite all the representatives of the member states and of the European rail sector, including now also the combined transport operators. And we make every year a dedicated campaign to collect information from the implementers, where they are with the implementation of the different functions of the TSI. We have now in average 600 to 700 responses per year of the implementers, which is quite a huge amount if we take into account all the wagon keepers, railway undertakings, and infrastructure managers, and of course all the combined transport operators. So this is how we are working, and of course if we detect that in a given country, for example, the operators, they are little bit behind schedule, then we make a dedicated information session, dissemination events in the country, or we encourage the people to apply for CEF funds because it gives money to them for extra money to get money for IT projects for the implementation of the DAF TSI.
That's very clear, and globally speaking, working in the, let's say, with customers and partners that are in the day-to-day operation in railway undertakings, infrastructure managers. I personally see that the direction taken by the regulation and this goal of soft compliancy. I think it's the right step. I mean, in order to have really this, massive implementation, and also to be useful for merely railway actors, because the truth is that the supply chain is relying on railway actors, but there are many others that are not railway actors that should be part of the game and should be facilitated, such as the combined transport one operators, that should be facilitated, in order to implement this. And with these soft compliancy, this is for sure, at least in my opinion, a very good step forward. And I think that further projects could even help this extension in the logistics sector. And there is really room for maneuver there to move on in this respect. It's 26 past 10, I think perfectly in time. It was great, really. I really thank all the speakers. It was really nice to have you here, and very good content, really. I've been learning a lot during 1 hour and a half, and thanks for that. We'll come back for sure with other, let's say, events also related to projects we are running, such as the one I mentioned before, iRail in CEF, that is exactly about the topic we are talking about, the extension of DAF TSI. So thanks a lot to the speakers, to the organization. Don't forget that the next events we have today, at 12 o'clock, we are moving again to the maritime sector. We are talking about very specific innovations, namely autonomous vessels for feeder container movements. We are talking about autonomous mooring. We are talking about matchmaking platform between offer and demand for logistic actors. So it's a very interesting topic to be treated 12 o'clock. And at 2 p.m. we have an interview. We are interviewing the head of port process solution at the port of Hamburg, Fantian Zusongdam. Sorry, it's quite complicated. It's Thailand, so it's quite complicated. And we have this recorded interview. We recorded already the interview, and you are going to see later at 2 p.m. And then tomorrow and Friday some others. So thank you very much, and enjoy the day, and keep in touch with the development in the railway sector. Enjoy. Bye-bye.
Many thanks. Goodbye.
Bye-bye.
Thank you. Bye.